My name is Raha Omar, and I will be presenting with my group 1 today about adaptive multi-factor access control.
This is David Michaelis with Group 1.
I'm Sivanaga from Group 1 as well.
All right.
So what is the problem that the tool aims to solve to the level and subproblem? So the current access control models do not provide adaptive and dynamic solutions. Multiple attributes of a user are not considered in their design. It has fixed access rights with no provision for temporary changes. Why is it a problem? There are approximately 30 million attacks occurring each year. Current trust models do not make systems immune from such attacks. Next slide. Hello? Oh.
You see it there?
Yes. Severity of the problem is high, and the goal is the contribution to access control model by considering various significant user attributes adaptive to different environments. What must we know about in order to understand the problem solution? One means of enhancing security of transmission is by the implementation of adaptive multi-factor access control, which utilizes a variety of shifting inputs to evaluate the trustworthiness of user based on their activity and the resources they are seeking to access. This multi-level evaluation distinguishes multi-factor access control from multi-factor authentication, a similar and related process that requires users to input multiple forms of identification to verify their identity rather than a simple username and password.
Over the course of our research, we found a number of different approaches that we learned from and drew from. The first of these that we'll discuss is Lin et al. From 2014. They proposed a multi-factor access control model which combined authentication with a trust score and assigned a trust score based on various factors. But this was based on a different type of access control model, not attribute-based. The model showed promise, but it required a high mutual trust threshold, which means that it needed multiple interactions with each user in order to really develop a trust model that was going to keep it effective in being able to allow access without unnecessarily limiting access to authorized users. Omitov and his co-authors in 2018 broke down a number of different approaches to multi-factor authentication, pointing to 3 different types of factor groups that are available to establish credentials: knowledge factors, ownership factors, and biometric factors. So something the user knows, such as a password or secret, something the user has, such as a card, smartphone, or token, and biometric factors being something the user is, such as fingerprint, and iris scan, other factors such as that. And by combining several of those factors, it can be possible to reasonably establish identity versus just using a username and password alone. Soon in 2020, and with no co-authors, he sought to develop a flexible trust-based access control model due to the challenges and limitations around implementing complex cryptography across a distributed cloud computing network. He proposed using a weighted trust decision factor, which incorporates evaluations of risk and obligation, as well as the trustworthiness of various user attributes. And so here's a diagram of how his access control relationship model works in terms of how the various factors are considered in the decision-making process. I'll throw things over to Kirthi to talk about our tool.
Okay. So based on the guidance we received from the research papers which David just discussed, we built our tool. So our tool has a trust model based template. So it considers different user attributes, and we have categorized into 4 different categories like subject attributes, resource attributes, operation attributes, and environment attributes. And so all these different attributes, we came to 12 inputs. So how does it work? So this our tool has 12 inputs. So each one will have a score value, so which will impact the trust score. And once the trust score is determined, the level of access is given to the particular user. So what are the different key design decisions that the author makes? So in our model, we have one important decision we made was that we considered a wide range and prominent attributes of the user to build the trust score. Which we thought was missing in other trust models, and also based on the actions performed by the user after the user is into the system, like the actions can be like accessing different resources or different other operations, the access levels changes dynamically. So the access rights for a user after the user is into the system is not fixed like in other trust models. And we also provide a balance between accessibility and security, considering that the users should also be very comfortable with the system, and it should not be the system should not ask too many authentication and access control questions and credentials from the user. So what was the rationale for those decision is that we made the model very adaptive. Like the initially we are considering subject attributes and environment attributes. We'll see in the slide like what are those subject attributes and environment attributes. And then once the user is into the system, we further consider resource attributes and operational attributes. So based on all this, the trust score is updated. So this one is a very important table we have come up with, which explains the different attributes we are considering to build the trust model. So each attribute is assigned a positive, negative, and a neutral value. Over the course of trust evaluation, all the values are computed to create a trust score, which then determines the next steps in the access process. So let's take a look of the previous slide, please. Yeah, just going through few of the factors, like the first one is an type of the user, the role of the user, guest authenticator or administrator user, which type of device is the user using, mobile, laptop, and what kind of device, whether it is given by company or not registered equipment, which is again based on MAC address, and what type of network the request comes from, like which Wi-Fi network is the user is using, and whether the Wi-Fi network is public or it is not secure or something, and what are the different resources the user is accessing once the user is into the system, and what kind of operations like read or write or execute, and whether the user is accessing the system from the trusted location or non-trusted location, whether the access is within the business hours or outside the business hours, whether it's a weekday or weekend. So based on that, there is an score impact, like for the type, like if you are considering the company network or non-company network, it's like company network +5 and non-company network -5. So these are the different attributes and the score impact for this one, which is very important for our trust model. Yeah, next slide. So based on the trust score which we build from the model, we give full access, and we give full access with additional authentication factors, or we give a partial access. And in some cases where the trust score is low, we give access blocked for 12 hours. And if the trust score is too low, we give the access permanently blocked from the MAC address. So this is how the access controls are designed based on the trust score. So we have a wide range of access levels in our access control model. Yes. So this is what I just explained. So the trust model will get inputs from resource attributes, subject attributes, operation attributes, environment attributes. So once the authentication process is done and the request comes to the access, the trust model gets initialized and the trust code is built, and then uh, once the trust code is built based on the other attributes like resource and operation attributes, either additional authentication is required or full access is granted. So in it, an additional authentication required, the user may get access or may not get access. So we have two cases where the access is denied or partial access is granted. In case when the resource attributes and the operational attributes are good, then full access is granted, and high sensitive resources, non-sensitive resources, sensitive resources can again be accessed, and again the trust code may change dynamically. So this is the whole flow how our tool functions, right from the authentication till the dynamic changing of trust codes. Yeah, David will be taking the slide from here onwards.
We were not able to do a direct evaluation of the tool because we didn't have time to complete the construction of the tool. However, based on the literature review and the methods described within the other projects that we reviewed, our tool uses similar, though not the same processes, and combines some different pieces from various different approaches to create a decision structure that evaluates the decision structure that we use to evaluate access requests. Did the authors discuss any interesting insights or implications for design based on their work? We believe that there are a number of interesting implications for the design. Some approaches use algorithms, but being able to implement an access control policy that both takes into account the various attributes and inputs, as well as being able to be dynamically adapted to different environments is an approach that a number of different authors took, and ours falls within the middle of that, broadly wanting to be adaptable in terms of how it evaluates, as well as how it evaluates the initial request for access, as well as how it evaluates user behavior within the environment, and weights various factors that it considers in making its decisions. Future work, a big area for future work is distributed access control models for cloud computing and other distributed computing network models. Managing access control within the cloud environment generally, within federated cloud models, there's a need for fine-grained access control based on identity attributes. And that does present additional security complications that accompany remote access to resources. Additionally, we looked at some approaches that explored the concept of using a key distribution center, which would provide users with unique keys for access to the cloud. And so each key owner would decide the attributes that would to require of users, and would manage their own access policies. And so each unit within the cloud could determine who it gives keys to and why. So those were some interesting approaches that we looked at that merit further research. The factors we've chosen are similar to those tested effectively in the models detailed by Liu, Lin, Sun, and Kays. While there's need for refinement, our model effectively lays out inputs and decision factors that reflect and contribute to an enhanced security environment. New adaptive approaches will be needed to secure data on the cloud and in other distributed environments. And so this model offers a contribution to those efforts, an approach that merits further study going forward. These are some of the resources, and the full resources are detailed in our paper.